Hi friends, this is the first topic of numerical ability, which is sets and Venn diagrams. The questions in GATE are not directly asked from sets and Venn diagrams. Sometimes it may be asked, but most probably these are useful in solving the probability problems. So let us see what is the definition of a set. A set is a well-defined collection of objects. For example, there is a rule like this: numbers exactly divisible by 3. If we write all the elements satisfying this rule, then we call it as a set. Set of numbers which are divisible by 3 is 3, 6, 9, 12, and so on. So these are the numbers which are exactly divisible by number 3. This is a representation of set. It is represented by flower brackets. The sets are denoted by capital letters A, B, C, D, like that. For example, this is a set A. And the elements of the set are represented by small letters. For example, let us say set of vowels. A is a set of vowels. Then we write the elements of set as A, E, I, O, U. This is set of vowels. A is a set of vowels. Then A, E, I, O, U is elements of set A. The elements of set are represented in two types of forms. There are roster form and set builder form. What is roster form? It is also called as list form. In this, the elements are directly written in the set, and in set builder form the elements are written in the form of a rule, so that it is also called as rule form. In roster form, for example, let us say 1 2 3 4 are the numbers of a set A. Then in set builder form, how do we write this? It's written in the form of variable satisfying the rule. So let us say that variable is x such that here what are the numbers? 1 2 3 4. These 1 2 3 4 are the numbers. Which numbers? Natural numbers. 1 2 3 4 are natural numbers ranging from 1 to 4. So 1 less than or equal to x less than or equal to 4. And what is x? X belongs to natural numbers. This is the rule, right? This is the rule, and these are the elements of set. So this is how we write in set builder form and in roster form. These symbols, these inequality symbols represent if there is only less than, if it is 1 less than x less than 4, then the numbers will be 2 and 3, excluding 1 and 4. If it is less than or equal to, then including these numbers 4, then it will be 1 2 3 4, including 1 and 4. It should be remembered that less than or equal to or greater than or equal to means including the extremes, and if it is only less than or only greater than, then excluding the extremes. So what is a finite set? These are the types of sets, different types of set. What is a finite set? If a set contains finite number of elements, then it is called a finite set. For example, these are the prime numbers 2 3 5 7 11, prime numbers from 2 to 11. This is a finite set. What is infinite set? A set containing infinite number of elements which are uncountable. So these are the numbers divisible by 2, 2, 4, 6, 8, 10, and so on. What is a universal set? Every element of every set is an element of universal set. For example, let us say a universal set can be represented by u or x. For example, a universal set is there which is set of natural numbers, and there is a set A having elements 1 2 and 3, and B is a set having elements 3 4 5 6. If you see here, these 1 2 3 elements and 3, 4, 5, 6. These are the elements in the natural numbers, right? So this natural numbers is a set called universal set, which means every every set is a subset of universal set. Let us see what is subset. First, let us see what is null set. A null set is a set containing no elements. If there is a if there is no element in a set, then it is called as null set. This is a set builder form of null set. Example: x such that 2 less than x less than 3. We have seen the before that 2 is less than x. For example, it is if there is less than symbol, then it will be excluding extremes. If there is less than or equal to, including extremes. So here it is only less than, so excluding this 2 and 3. So between 2 and 3, what are the elements present? In natural numbers, no element is present, so this is a null set. Null set is represented like this empty set, or it can be represented with 5. Two types of representation for a null set. One is open flower brackets, and another one is 5. Next set is singleton set. A set containing exactly one element is called singleton set. If we see here example, x such that 2 less than x less than or equal to 3. Here less than or equal to symbol is present, so it will be including the 3. Then what is the element? It will be 3. Excluding 2, including 3. What are the elements present in natural numbers between this? Only 3 is the element which is present in natural numbers. If it is rational numbers, then elements between 2 and 3 will be 2.5, 2.7. All these elements will be present. But as it is in natural numbers, only numbers should be considered. So then next one is equivalent set. A and B are said to be equivalent if they have equal number of elements. Two sets are said to be equivalent if number of elements is same in both the sets. Let us say if A is a set containing elements 1, 2, 3 and B is a set containing 3, 5, 7. If you see here, number of elements in A, number of elements is represented by n of A is equal to 3, and number of elements in B is also equal to 3. So here n of A is equal to n of B. If number of elements in A is equal to number of elements in B, then A and B are called equivalent sets. Then what are equal sets? A and B have same elements, then A and B are said to be equal sets. For example, A is a set having 2, 3, 4 elements, and B is a set. This is represented in roster form and this is represented in set builder form. So if you see here, B is a set having natural numbers from 2 to 4 including 2 and 4. So what are the natural numbers including 2 and 4? Including 2 and 4, between 2 and 4, 2, 3, 4 are the elements. So this and this are equal. If A is equal to B, then A and B are said to be equal sets. If n of A is equal to n of B, then they are said to be equivalent sets. I have said in a universal set that every set is a subset of universal set. Every set is a subset of universal set. So what is the meaning of subset? Sorry, it is universal set. So what is the meaning of subset? Let us see it now. If every element of A is in B, then A is said to be subset of B. This is the representation of subset. So if every element of A is in B, then A is subset of B. For example, let us say A is a set having elements 1 and 2 and B is a set having elements 1, 2 and 3. If you see here, 1 and 2 elements are present in B. So A is subset of B. Number of subsets of set containing n elements is given by 2 power n. So what are the from this set A, how many subset we can make? We can make element 1 as a single set and element 2 as a single set, and combining both elements as another set, and empty set is also a subset of this one. So we get here 1 2 1 2 and another one is empty set. 4 subset we are getting for number of elements 2. It is given by number of subsets of a set containing n elements is 2 power n. So here 2 power n is 2 and the number of subsets is 2 power 2, which is 4. Then what is a proper subset? If every element of A is in B and there is at least one element in B which is not in A. Let us say A is equal to 1 comma 2 and B is also equal to 1 comma 2. Then these are said to be A is subset or equal to B. If B has an extra element 3, then A is only subset of B and it is not equal to B. This is what proper subset is meaning. So B should contain at least one element more than A. Then A is proper subset of B. Let us see an example. A is having 1 2 and B is having 1 2 3. And while representing the subsets, proper subsets, what are this? Element 1 is subset of B, element 2 is also subset of B, and we should not represent while representing proper subset, we should not represent the whole subset. As we see here in subsets, we represented 1 2 combined 1 2 as a subset of B, but here this 1 2 cannot be represented as a proper subset of B. So we can represent 1, we can represent 2 as a subset, and we can represent empty set as a subset of B. For this, number of proper subsets of a set having n elements is 2 power n minus 1. But in subsets, number of subsets is 2 power n. Here it is 2 power n minus 1 because excluding the total set. Here we get 3 subsets because 2 power 2 minus 1. Number of elements are 2. 2 power 2 minus 1, which is 4 minus 1, which is 3. This is a proper subset. Next, let us see what is power set. Set of all subsets of A is called power set of A. Let us see an example. If we write all subsets as a set, then it is called a power set. That's it. A is a set having elements 1 and 2 and B is a set having elements 1, 2 and 3. So what are the subset we can get here? Element 1 is a subset of B, element 2 is a subset of B, and the combined total set is a subset of B, and also null set is a subset of B. If these all subsets are represented in a set, then it is called a power set. This is a power set of A. So number of elements in a power set is 2 power n. As number of subsets is 2 power n, then number of elements of a power set will be 2 power n only. Next, what is superset? If every element of A is in B, then B is a superset of A. It is represented like this. B is superset of A. Actually, this is another way of representing the subset. We can also write this as A is subset of B. Here B is the superset. It is like a parent one. Here 1 and 2 are the elements in A and 1, 2, 3 are the elements in B. These elements are present in B. So A is subset of B. It is also said as B is superset of A. So these are the important formula to remember. Number of subsets of a set having n elements. We have seen that 2 power n is the number of subsets. Number of non-empty subsets having n elements. If we see here, 2 power n is the number of subsets including the null set. And here if you see number of non-empty subsets, which means excluding the null set. How many null sets will be there? Only one null set will be there in all the subsets. So excluding this, it will be -1. Number of proper subsets having n elements. What are number of proper subsets? 2 power n -1, because excluding the total set, which is -1. And if we see number of non-empty proper subsets, 2 power n -1 is the number of proper subsets. Number of non-empty proper subsets is 2 power n -1 and again -1. It will be 2 power n -2. So these are to be remembered. Similar to arithmetic operations we do in casual mathematics, 2 plus 3, 2 plus 2 minus 3. Similarly, in sets also we do operations. First one is union of sets. What is union of sets? Union is if there is a set A and set B, let us say A is having elements 1 and 2 and B is having elements 2, 3, 4. The all elements combining these two sets is called union of set. Here 1 and 2 are present, here 2, 3 are present. If we combine A and B, we get 1, 2, 3, 4. We should not repeat the common element. We should not write 1, 2, 2, 3, 4. We should not write this. This is the same element, 1, 2, 3, 4. So this is the union. This is the Venn diagram. What is Venn diagram? Representation of sets in a diagram, which is called Venn diagram. This is universal set. See here, the universal set is 1, 2, 3, 4, 5. From this set, A is having elements 1 and 2 and B is having elements 2, 3 and 4. If you see here, this is the set A and this is the set B. A has elements 1 and 2. B has elements 2, 3, 4. So 2 is the element common for both A and B. And 5 is the element which is in universal set. So what is A union B? A including B. This is A union B. Next one is intersection of sets. It is represented by A intersection B like this. For example, universal set is 1, 2, 3, 4, 5 and A is a set having 1, 2, 3 and B is a set having 2, 3, 4, then A intersection B. A intersection B is common for both the sets. Here if you see 2, 3, 2, 3, these are the common elements in A and B. This is the intersection of sets. So A intersection B is 2 and 3. If we represent this on a Venn diagram, A is a set having elements 1, 2, 3. B is a set having elements 2, 3, 4. The common for this both sets is 2 and 3. So this is a representation of intersection of sets. And this is the universal set having element 1, 2, 3, 4, 5. And next operation is difference of sets. Elements of A which are not in B, then it is said to be A minus B. What is the meaning of A minus B? Elements of A which are not in B, which means only A elements. Let us see with an example. A is a set having elements 1, 2, 3 and 4. B is a set having elements 4, 5 and 6. What are the elements of only A which are not including any other elements? If you see here 1, 2, 3, 4 and here it is 4, 5, 6. 4 is the element which is in B, which means it is not only A. So A minus B gives 1, 2 and 3 excluding the element which is in both A and B. If we represent this on a Venn diagram, this is A, this is B, 1, 2, 3, 4 are the elements of A and 4, 5, 6 are elements of B and 1, 2, 3, 4, 5, 6, 7, 8 are the elements of universal set. So what is A minus B? Only A, which is this one. This is the only A. Next one is symmetric difference. Union of sets A minus B and B minus A. What is A minus B? A minus B is only A, and B, what is B minus A? It is only B. And it also said as only A and only B. It is represented by A delta B. A delta B is represented this in roster form. It is X such that X belongs to A minus B or X belongs to B minus A. Here A minus B union B minus A. This is the definition of symmetric difference, right? It is also can be represented as A union B minus A intersection B. If you see here, this is universal set. What is symmetric difference? A minus B. What is A minus B? This is A minus B. Only A. And what is B minus A? This is B minus A. Only B. All the elements of A minus B and this A minus B and B minus A is said to be symmetric difference. And also it is there another formula that A union B minus A intersection B. If you see here, what is A union B? This is A union B, right? And what is A intersection B? This is A intersection B. If we take A union B and minus this one, we will be getting this one and this one. So it can also be represented as A union B minus A intersection B. So next one is complement of a set. Elements which are not in A is called complement of A. So A complement is represented as A dash or AC. A complement is equal to X such that X belongs to universal set and X does not belongs to A. all the elements of universal set not including A is called complement of A. Let us see with an example. There is a universal set which has elements 1 2 3 4 5 6 7, and there is a set A which has elements 1 2 3, and there is a set B which has elements 3 4 5. So then what is the A complement? A has elements 1 2 3. The remaining elements which are in universal set are 4 5 6 7. This is what A complement mean. If we represent it on a Venn diagram, this is U, this is A. Elements excluding A are this area. The shaded area is A complement. Then there is a type of joints which are known as disjoint sets. We have seen equal sets, equivalent sets, and now let us see disjoint sets. A and B are disjoint if there is no element in common. No element in common with A and B. A is a set having some elements, let us say 1 and 2, and B is a set having elements 3 and 4, and universal set is 1 2 3 4 5. If you see here, there is no common element present in between A and B. So these two sets are said to be disjoint sets. When two sets are disjoint, then it will be a null set. Intersection of these two sets will be a null set. If we represent it on a Venn diagram, it will be like this. This is a universal set, and this is A, and this is B. This A and B are not having any common area like this. This is a representation of disjoint set. Some important formula are to be remembered while calculating while solving the problems of sets and Venn diagrams. There is no need to remember, but in gate, speedness is also important, so that we need to remember the formula. Without remembering this formula also, we can solve the problems. So let us see here. Number of elements in A union B. How to find the number of elements in A union B? If you see here, this total is n of A, and this total is n of B. But there is a common section here. If we add n of A and n of B, these elements these elements common for both A and B are added twice. So we need to subtract 1 of A intersection B. So adding this n of A and n of B, we add 2 times the intersection part. So we need to remove the one intersection part. So it is n of A intersection B. If we write it as a formula, n of A plus n of B. This is the number of elements of A and number of elements of B minus n of A intersection B. Subtracting the number of elements of A intersection B, we get n of A union B. It is also can be represented as n of A minus B, this part. N of A minus B is this, n of B minus A this. If we add these two and also add this intersection part, we get n of A union B. This is n of A minus B, and this is B minus A. If we add these two, it will be n of A minus B plus n of B minus A. And if we add this also, it will be n of A minus B plus n of B minus A. This is n of A minus B, this is n of B minus A, and this is A intersection B, n of A intersection B. If we add this all, we get n of A union B. This is the important formula we need to remember. And next one is n of A minus B is equal to n of A minus n of A intersection B. Just now we have seen this same type one. what is n of a minus n of a what is a minus b? Only a. This is a minus b. What are the elements number? What are the number of elements in a minus b? If you take this total n of a minus this part, we get n of a minus n of b as, sorry, n of a minus n of a intersection b as n of a minus b. So listen again. This total is n of a, and subtracting this part n of a intersection b, we get n of a minus b. And there is also another formula, n of a intersection b complement. What is a? This is a. And what is b complement? B complement is this is a, right? And b is this, all is b. N of sorry, a intersection b complement. The common area for both a and b complement is this one. This is the common area we got. That is n of a minus b. This is n of a minus b. And next one is n of a union b union c. In order to remember this, let us say, what is n of a union b union c? This total one. Number of elements in this total is n of a union b union c. For that, let's say this is n of a and this is n of b, this is n of c. If we add n of a, n of b and n of c, we are adding this and this also. So we need to subtract this first. N of a plus n of b plus n of c minus subtracting this part, which is n of a intersection b, and subtracting this part n of b intersection c, and subtracting this part n of a intersection c. But while subtracting these three parts, this part is this a intersection b intersection c is also subtracted, also got subtracted. So we need to add this part. So if we add n of a and n of b, these elements are added twice. So we need to subtract n of a intersection b. And here, if there is another c, we are adding b and c twice. We need to subtract one part, b intersection c. And here also minus a intersection c. And if we are subtracting these three parts, the intersection part for all the three sets also gets subtracted. So we add a intersection b intersection c. So let us see the formula now. N of a, this total, plus n of b, this total, and n of c, this total. And these elements are added twice. So n of minus n of a intersection b, we are removing this part, and we are removing b intersection c part, and we are removing c intersection a part. If we are removing this, this also gets removed, but it should be included, right? So plus n of a intersection b intersection c. So including this, we get this formula, n of a plus n of b plus n of c minus n of a intersection b minus n of b intersection c minus n of c intersection a plus n of a intersection b intersection c. These are to be remembered. These formula are enough for solving the sets and Venn diagrams. In next part of this video, let us solve some problems. Okay. If you like this video, please like, share and subscribe. Thank you.